Hello everyone. Welcome to joining today's AIC webinar on next generation hyperconverged solution on AIC AMD platform. This program is conducted by AIC, ADEC, and AMD organizations. I'm your host, Narendra Sharma, Regional Sales Director covering the business of AIC in market of India. Let me provide you some of the webinar logistics here. In all, there shall be 3 presentations. In sequence, the first one shall be from AIC to be followed by ADEC Technologies, and then the final one shall be presentations from AMD. For all your questions, please type in your questions into the question box, and these questions shall be picked up for answering in the Q&A session at the end of the webinar. After the webinar, 3 separate Zoom rooms shall be opened for a detailed discussion with each of the presenters. You may check for these links to the Zoom rooms later in the chat section. The presentations being run by the presenters shall also be available from the handout section. So now let me kickstart this program by inviting Mr. Vincent Lee, the Business Development Director for Cloud Business from AIC, to introduce AIC's AMD-based multi-node server solutions.
Good day, everyone. It will be very exciting to introduce AIC's latest AMD-based multi-server node solutions against virtualizations and density requirements. Hopefully, you will find more interesting in the following page. I'm Vincent from AIC Cloud Business Development Department. I have more than 20 years experience in IT industry, which including 16 years activities in the server computer markets. I was involved in different components business models such as metal server chassis, server member, complete server system assembly, and even with the third-party solutions integrations such as Cloud Sas, object and block-based storage, NVMe all-flash array storage, and hyper-converged during these years. Let's get started to have a look about the AMD platforms. HP201AG is a 2U4 server node chassis to supporting maximum 24 hard swap NVMe storage device in front, which means per node is with 6 U.2 plus 2 SATA 2.5-inch SSD plus 2 SATA or PCIe M.2 SSD. Single AMD Epic second generation CPU sockets, CPU TDP up to 180 watts, 8 memory slot, 3 PCIe by 16 Gen 4 slots, and the 1+1 redundant 1600 or 2000 watt power supply. HP202AG is also a 2U4 server node chassis to supporting maximum 12 3.5-inch hard swap SATA storage device in front, which means per node is with 3 3.5-inch hard drives plus 2 SATA 2.5-inch SSD plus 2 SATA or PCIe M.2 SSD. Single AMD Epic second generation CPU sockets, CPU TDP up to 180 watts, 8 memory slots, 3 PCIe by 16 Gen 4 slots, and 1+1 redundant 1600 or 2000 watts power supply options. From this page, you can see more details about these multiple Arica specifications. Through AIC Max I/O design supporting, all PCIe lanes can be extended to the front or rear for most devices supporting On board is supporting 8 memory slots, which you can consider 32G, 64G, or even 128G RDIMMs for higher VM numbers supporting. 3 aiding cards device can be placed into the same nodes. For example, one NIC for data connections and the other NICs for node cluster communications. Here is the internal view. Today you know how the signal NIC with a better mechanical design. All nodes are with connector connections without cable. Through this kind of cableless design, it can be easy to do the maintenance for server nodes exchange without system downtime considerations. HP201AG is designed to support multiple interface devices. Each node can either with 6 NVMe SSD in front or 4 NVMe SSD plus 2 SATA SSD or hard drives, or 6 SAS or SATA SSD hard drives supporting. It is because the chassis backplane is already with tri-mode interface supporting. However, for SAS device connections, it requires additional RAID HBA aiding cards for SAS interface enabling. Aic 2U4 server node platform is the best solutions, such as to supporting the latency-sensitive mobile edge computing workloads, and at the same time to meet space limit conditions at edge size. It is a high-density design for combining the computing, storage, and network in one compact chassis against hyper-converged environments. Support maximum 4 CPU, 32 memory slots, 24 NVMe U.2, 12 PCIe by 16 Gen 4 aiding cards device in one 2U chassis. Let's summarize the key features as below. High storage density, high expansions, and high flexibilities. For high storage density, each node supports 2 SATA NVMe M.2, 2 SATA 7mm SSD, 6 U.2 NVMe, or 3.5-inch hard drives. High expansions, each node supporting 3 PCIe by 16 slots, which including 2 half-heights, half-lengths, plus 1 OCP 2.0 mezzanine. High flexibilities. AMD Epic various generation available by BIOS firmware upgrades. Both 24 2.5-inch and 12 3.5-inch solutions are all available, and OEM storage options against various different type of storage requirements. And for PSU, it is supporting 600 watts or 2000 watts options. Aic is working with AMD very closely for new generations readiness supporting. You don't need to worry to get in the old generation products at this moment, as the same platform can be easily to upgrade to the Epic's next generation CPU without any major hardware replacements. For next generation CPU, it is supporting better performance per watts. And for the platform, it will be supporting higher CPU TDP without any problem. The launch schedule will be Q2 this year. Following are with some use case for your reference. AirDeck is an AIC ISV partner for next generation's HCI solution providing. 3 major key features from AHCI: multi-tier storage support, flexible storage tier utilizations on different VM tasks, mix old and new hardware platforms. I won't spend more time to introduce, as the Aic CEO will give you more ideas just right after my sections. But from here, you can understand for how this AHCI fully utilize some AIC platforms. 3 different tier storage supporting in one chassis and also reserve the NIC heading card space for both cluster and the admin network supporting in one compact 2U chassis. This use case is about large data center customers with compact compute node requirements. From this DC customer's requirement, the server specification should be as listed here. 2U4 node in one chassis, AIC Ariga's single AMD CPUs multiples with high core counts, A memory for 64G and TPM 2.0. 3 PCIe slots should be available, one for the dual-port OCP NIC 25G, one for the RAID HBA, and one for the SSD cache future upgrade. 2 3.5-inch SATA hard drives for applications, 1 SSD for OS purpose. The application is for the virtualization compute node request. The major preference for AIC HP202AG is easy deployments with high space saving considerations. For traditional x86 high core count compute node with more expansion slots requests, it has to be with 1U, 1 server node discrete form factors. The AIC platform is the first one to come out such idea for helping customers with a more powerful performance and more space saving. Plus, all drive device carriers are designing for screwless and top covers toolless for much helpful during the large number servers deployments. Some clues showing here to let you understand for how AMD platforms can help customers saving their investments. Please help yourself to find the more details. Next is a live demo for you understanding more about AIC real systems. AMD platforms. Each terminal is supporting one single socket with A memory slots maximum. The same design with 3 PCIe by 16 slots supporting, which including 2 half-heights, half-lengths, plus 1 OCP 2.0. All the PCIe store is a Gen 4 interface. On board is also supporting 2 M.2, either for SATA or the PCIe interface. That is also with the same cableless designing to extending all the interface from the board level to the front device. And that's also same cableless design for server nodes hard plug without system interrupt supporting. It is supporting either 24 2.5-inch or 12 3.5-inch device. All the storage device designed by AIC, which is the school is supporting. Two and a half inch with a screw design also. And each node is supporting individual power buttons, and LED for the system status alerts and the indications. The system is supporting 1600 watts or 2000 watts as options. And with the AIC special design, each server node is with an additional two 7mm SSD device supporting. Either is supporting OS or the cache purpose. And this storage carrier is also the toolless design. And for the cooling systems, all the fan is a hot swappable, which can be easily for maintain and exchange. All right, thank you for watching. If you have further questions, please visit our website or contact regional sales for more information. Thank you for watching AIC's latest AMD platform. I will forward the sections to Mr. Vince Guang, the CEO of AirTech, for next generation's hyperconverged solutions introductions.
Hello, everyone. My name is Vince Guan. I'm a co-founder and the CEO of AirTech Technologies. We are a company located at the Silicon Valley in US. I'm going to give you a brief introduction of our product called AHCI. What is AHCI? AHCI stands for Adaptive Hyperconverged Infrastructure. It is a new cloud infrastructure solution that evolves from HCI. It's a software suite that runs on off-the-shelf servers. It is adaptive in the sense that it allows users to tailor different software-defined resources in an infrastructure to best fit their applications. So why do we need AHCI? Or why HCI is not good enough? The reason is because HCI only comes with a single form of storage. But applications are not all the same and need to have different types of storage in order to perform. AHCI is designed with a versatile software-defined storage system that allows users to customize different forms of storage so that the infrastructure can support all kinds of applications. Let's take a look at the different storage options provided by AHCI. It includes three major types: scale-out, close-coupled, and local-coupled storage. First, scale-out storage. This is functionally the same as storage offered by other HCI solutions. VM data are broken down into small chunks and distributed across all nodes. Data reads and writes go through the network, so latency is high and performance is limited. Second, closed-coupled storage. In this type of storage, VM data are co-located with the VM on the same node. Data reads and writes are primarily on the node, but write data are also replicated to some other nodes. Latency is reduced because most data access happens within the node. Only replication data need to go through the network, so it has better performance. Third, local coupled storage. In this type of storage, VM data and VM are co-located on a single node without replicating to any other nodes. Data reads and writes are completely within the node without going through the network at all. So latency is minimum and has the best performance. Here are some benchmark test results of the three types of storage. Generally speaking, compared to the scale-out storage, close-coupled storage can perform 4 to 10 times better, and local-coupled storage can perform 8 to 20 times higher, depending on the actual configuration, of course. Next, I'm going to go through a few other major features of AHCI. One is the Ahci cluster management. What it does is to monitor and detect any failure conditions in the infrastructure and perform either live migration or failover to move VMs to keep the VMs running without disruption or with minimum disruption. Here are a few examples of typical failures: server failure, network connection failure, and network partition. In each case, Ahci cluster management will move the affected VMs to servers in the healthy part of the infrastructure. Network partition is the most complicated scenario because from each server's perspective, it appears that there is no problem at all. But with Ahci cluster management, it is intelligent enough to detect it and perform necessary recovery. The next feature is dynamic load balancing. Dynamic load balancing is to normalize resource utilizations across all servers, so every VM can perform optimally without constraint by a server because some resource in the server is oversubscribed. Another feature is Utilization Visualization. It provides users the insights into the infrastructure, like CPU, memory, and network utilization on each node, and what VMs running on the node are the major contributing factors to the utilization. Here is an eye chart of the functional architecture of AHCI. In the interest of time, I will not go through each of them in details. To summarize, AHCI is a new and improved cloud infrastructure solution. It is as simple as HCI, easy to deploy and manage. It is more flexible and much higher performance than HCI. It is a very low-cost solution, simple software license, and the software runs on any commodity servers. This concludes my introduction to our product. Thank you for listening. Next, I'm going to pass on to Mr. Manmohan Brahma from AMD. Mr. Brahma, it's all yours.
Good afternoon. My name is Manmohan Brahma. I help customer defining the best and optimal data center solutions for AMD India. Today I will be giving a brief on the present day challenges in the modern data center and AMD's solutions to address the same. I will brief on the AMD Epic Roadmap and give you a quick update on the technology, how it is heading to and progressing. Globally, we see a significant growth of the data center market. We see it has led to opportunities across industries such as conventional defense, meteorological studies, manufacturing, BFSI, research and development efforts, etc. As India gets ready for the 5G network, we believe that the telecom sector will be one of the key sectors that will adopt high performance computing server CPUs over the next 2 to 3 years. High performance infrastructure will allow faster delivery of internet content and seamlessly roll out a host of next generation 5G applications. The demand for GPUs is seen continuous, and for machine learning, in order to refresh data center, enterprises are looking at software defined infrastructures to help them drive down operational cost and differentiate their products and services. AMD is tapping on this opportunity by working with ecosystem partners to highlight value propositions of AMD Epic server process and Radeon GPU for the new data center. India is a key data center market for us, owing to the rapid increase in adoption of emerging digital technologies by not only technology focused companies but also traditional legacy companies. India is close second after China, and today India is poised to become the second APAC for data center systems and solutions. NASSCOM predicts growing adoption of data center for data science, artificial intelligence, machine learning, and high performance computing. Is pushing the web scale application spending by 7.2 billion by 2022. With this massive growth, the major challenge which enterprise face are energy efficiency and security. With the global and new local cloud service providers growing their presence in India, AMD Epic based server platforms are positioned to help them deliver high workload performance with power efficiency and optimal density. Since 2017, we delivered significant innovations to the data center market. We outlined an aggressive roadmap of leadership products, building on the executions for our first and second generation server processor, and a detailed plans to drive continuous innovations across a wide range of growing market within the data center. We are powering the future of exascale computing with our CPU, GPU, and interconnect and software products. One of the latest example of collaboration with innovation is the recently announced El Capitan supercomputer at Lawrence Livermore National Laboratory, which is expected to come online in 2023. El Capitan is expected to deliver more than 2 exaflop of double precision performance, making it to be a powerful more than 200 fastest supercomputers combined together. We are continuously gaining traction with the second generation AMD Epic processors in enterprise, cloud, and HPC markets based on delivering the performance leadership and TCO advantages across the most important enterprise workloads like cloud. In 2021, we expect more than 150 AMD Epic processor power based cloud instances and 140 server platforms to be available. Also, we are unlocking accelerated computing with new technologies including AMD CDNA architecture, third generation Epic processor, third generation Infinity architecture, and Radeon Open Compute software platform. AMD is proudly partnered with ORNL to deliver the world's first exascale supercomputer, Frontier. And that will feature custom CPU and GPU technology from AMD and represents the latest achievement on a long list of technology innovations. We have contributed to the development of Department of Energy exascale programs in the United States. The AMD innovations that will be used in Frontier systems include the future generation high performance computing and artificial intelligence optimized custom AMD Epic CPU, the AMD Radeon MI Instinct GPUs supported by high bandwidth memory and extensive mixed precision operations for optimum deep learning performance. A custom high bandwidth low latency Infinity Fabric connecting 4 AMD Radeon Instinct MI GPUs to 1 AMD Epic CPUs per node. An enhanced version of the open source Radeon Open Compute programming environment taps into the combined performance of the CPU and the GPU together. Similar to the design for Frontier, we are applying our experience for advancing our CPU and GPU designs for El Capitan. The system will be another exaflop system targeted for the delivery in 2023. The various AMD technology within El Capitan includes the next generation AMD Epic processors codenamed Genoa, featuring the Gen 4 processor core. These processors will support next generation memory and IO subsystem for AI and HPC workloads. The next generation Radeon Instinct GPUs based on new compute optimized architecture for workload including HPC and AI. These GPUs will be used for next generation high bandwidth memory and are designed for optimum deep learning performance. All these good references which we discussed is driven by our commitment to the industry today and the leadership roadmap. The design of AMD Zen Core is started in 2015 with a commitment for the first ever Zen Core based processor AMD system on chip to be delivered in 2017. We stood with our commitment and we delivered AMD Epic first generation processor codenamed Naples in 2017. We promised for second generation AMD Epic processor codenamed Rome for the delivery in 2019, and in August 2019 we did it. So far we have shipped more than 260 million Zen x86 cores on our processors. We are working on the next generation CPU core, packaging and interconnect innovation, wherein we are planning to introduce the Zen 3 core targeting for the launch in March 2021. The upcoming AMD Epic processors will have third generation AMD Epic Infinity Fabric architecture with optimized CPU to GPU memory coherency that can enable significant performance improvements and simplify the software programming required for accelerated computing solutions by allowing the CPU and GPU to seamlessly and coherently share the same memory. The Zen 4 core is currently in design phase and is targeted to use the advanced 5 nanometer process technology. Where we are today is all due to the strong execution, leadership in performance and the ecosystem support. The strong commitment of roadmap is making us within the unprecedented time of the pandemic Despite the downfall in economy everywhere, we are seeing customers are interacting with us and are investing heavily on us because we are committed to the roadmap, and we are delivered and we delivered as we promised without failing. The present generation processor from us have up to 64 Zen 2 cores with increased instruction per cycle and leadership IO and memory bandwidth. Platform enhancement, including the industry's first PCI Gen 4 capable x86 server processor with double the bandwidth per channel, thus improving data center accelerated performance. The single socket Epic processor is outperforming a commercially available top of the line a dual processor from the competition, running computationally intensive workloads like industry standard spec CPU benchmark. One of the unique and interesting part of the AMD system on chips are platform with socket compatibility. So your investment is secure. If you are installing a system with Zen 2 core ROM processors, you may do a field upgrade of the CPU for improved performance upon the launch of the next generation AMD Epic processors. Business across sectors are focused on improving customers' experience as they innovate and scale in this age of digital transformation. In line with this, at AMD, we believe that setting up a comprehensively agile and reliable data center ecosystem will significantly empower the dynamic business to make smarter decisions. With the growing demands, organizations must ensure our hardware, software, and networking resources with services are in place and work in tandem. It is essential to collectively empower an agile and robust IT ecosystem and also fuel high performance computing capabilities. A strong IT ecosystem further powered by a modern and strong security solutions which harden the code that helps an organization guard the most important assets, which is data, while helping reducing the TCO. Now, here is a list of complete ecosystem of the AMD ecosystem powered by AMD Epic. We have got plenty of server platforms designed by different hardware vendors, and we have got plenty of ecosystem components which are very well supported by the AMD Epic processor. For us, 2020 was a very big year in terms of growth and opportunity, and we are confident of riding on this momentum. We have huge growth in opportunity in the data center market with our AMD Epic processors. With the launch of second generation AMD Epic processors in August 2019, we have brought in revolutionary capabilities of server performance, thereby setting up higher standards for the data center market. We are continuously bringing in a new wave of exciting innovations in the data center space, combined with better power, efficiency, optimization, scalability, and security without compromising in the total cost of ownership. The second generation Epic processor has already achieved over 140 performance world records with the capabilities to address a number of modern data center challenges through big data, virtualized environment, and HPC workloads. With performance similar to competing dual socket platforms in a single socket, AMD Epic delivers three strong pillars of data center: energy efficiency, workload balance, and security. The biggest ever challenge which most enterprises face today are the exceeding power and cooling budget and the software stack license cost. At AMD, we solve these issues by bringing in efficiency in semiconductor manufacturing process, which helps reducing the power and cooling by nearly 50%. Our partner TSMC manufactures our processors with 7 nanometer FinFET technologies. With the significantly reduced size of transistors compared to competitions, we are effectively able to optimize on per core power and improve on the frequency. Cloud environment need more compute on a denser footprint, more memory to power more VMs, more IO processing capabilities, and most important is the execution security. AMD Epic can have up to 64 Zen 2 cores with a power cap of 225 watt, up to 4 TB of memory and 128 PCI Gen 4 lanes. With the industry standard leading core count, Epic enables more VMs with more robustly configured VMs per server than previously possible. Whether you are deploying a single server or implementing a private cloud or enabling a hybrid cloud, AMD Epic provides a perfect balance of compute, memory, I/O, and security for your virtualized environment. For the end users of cloud, platform security is a major concern. Spectra, Meltdown, Foreshadow, all of these attacks have increased awareness that processor design choice are very much important to security. Side channel attack based on the subtle difference in processor state now can be exploited to expose customer software and data. AMD pioneered a new approach that makes design choice with security in mind. The AMD Epic family of processor helps protect your most important assets, that is data, from performance optimized countermeasures that help prevent certain side channel attack vulnerabilities to proactive encryption in memory. AMD Epic provides an advanced protection at scale for modern data center computing. Our CPU microarchitecture is designed with data isolation in mind. Data from different sources or from different threads are designed to be isolated from different threads within the CPU. In addition to this architectural level protection, the second generation AMD Epic processors increase security capabilities with performance optimized countermeasures against the known attacks. The AMD Epic family of processors sets a new standard for the secure memory encryption by making it possible to encrypt the content of the memory in the content of the main memory with only a change in the BIOS settings. With encrypted memory, integrity attacks such as cold boot attacks are unlikely to divulge memory contents because any data obtained is encrypted. High performance encryption engines integrated into the memory channels minimize performance overhead. All of these are accomplished with no modification to your software, which is very much important. To help maintain the promise of virtualization, second generation Epic also protects confidentiality by encrypting each virtual machine with a unique key that is known only to the processor. With up to 509 contexts, this helps protect confidentiality of your data even if a malicious virtual machine finds a way to your virtual machine's memory or a compromised hypervisor reaches into a guest virtual machines. Now, the fundamental question arises that why is like 509 contexts are there when you don't have this many threads in the system? Like we can have a maximum of 256 threads per systems. Then why we need 509 contexts? It is primarily because the way the cloud and data center environment are gearing up with the applications like Kubernetes or Dockers or containers. Even more fast CPUs can accommodate more containers. We are very much prepared for the future generation of computing for the security point of view. With this features, we are able to tap into a strong presence in the mega data centers and the major cloud service providers, starting from Microsoft to Twitter to Alibaba, Baidu, Tencent, and IBM, to name few. And we have got a massive presence in the local CSPs in India. You name the CSP, we have got a presence today. When you look at an Epic first generation, we brought to you the first mainstream multi-die approach to high-performance server processors. Presently, we evolved into a hybrid multi-die approach in the second generation. When we look into the advancement of core technology perspective, the move to the 7 nanometer FinFET technology made us different. We are not tied up to any internal foundry technology, so we can choose the right technology for the right product at the right time. The leadership of execution allows us to keep advancing the progress in the industry needs today. Thank you very much.
That was wonderful. Thank you, all the presenters from AMD, AIC, and ADEC. Uh, that was very good insights about the products and very helpful to understand the technology. Uh, with this, we move over to another interesting portion of our webinar, which is question and answer session. So I do hope we would have enough questions into the question and answer box section. Let me gather a few questions for answering from the panel speakers. Here we are. Okay, let me pick up the very first question for AMD, Mr. Manmohan. The question reads, how are AMD processors best suited to VDI infrastructure solutions over HCI platforms? Please do also share some of the USPs with the real examples. Mr. Manmohan, would you like to share some insights on this question, please?
Sure, Narendra. It was really a good question. AMD is totally geared up to capture into the HCI and VDI market. The 32 core and the 64 core processors are well suited for HCI and VDI applications. Especially for VDI, the three components that are very important is the core per socket, the cache per core, and the clock frequency per core. Now AMD is tapping into all the three sectors and is focusing on all the three sectors to make sure deliver a product which is well suited for the end customers. Now the other thing which I would also like to highlight is on the licensing policy. Now most of the applications, most of the HCI applications are licensed either based per core or per socket. So wherever we have got a per socket licensing, there the more the number of cores you have got, the lesser the number of license that you will be spending for towards the cost per virtual machine or per VDI instance. However, the place where you have got per core licensing, the typical trend and the general rule is for every 32 core you buy one license. Like for example in VMware or with any other HCI platform. So with the 32 core processors and the 64 core processor, that turns out to be the most sweet spot SKU for the end customer to leverage the full capability of the hardware as well as the software licensing policy. So that in turn actually saves a great amount of total cost of ownership by use of AMD processors. Yeah, over to you, Narendra.
Yeah, thank you, Manmohan. That is nicely, connecting the design advantages to good TCO commercials for the end users, quick adoption. Thank you. The second question I would like to ask Mr. Vincent Lee from AIC. The question is, will the AIC 2U4 node system support server node hot swap? Mr. Vincent, you'd like to pick up this?
Yeah, hi, this is Vincent from AIC. Well, actually, yeah, AIC's 2U4 server node, this hyper-converged solutions will be easily to supporting the hot swap server node. That will be helping the customers for the best maintenance and also the easy management. So that will be the good features to supporting all the customers when you doing the system supporting. Thank you.
Thank you, Vincent. I'll pick up this one. There is a good buzz around the licensing cost of the products. So this one is for Vince Guan from ADEC. The question reads, what is ADEC's software licensing model? Vince?
Oh, yes. Hi. Our licensing model currently is very simple. Basically, it's by socket, no matter how many cores in a socket. So as Mr. Momentum mentioned that, so this is actually give you a great advantage when you use our software combined with AMD processors, because AMD processor has, you know, a lot more cores in a single socket. So our license is also very competitive. It's a perpetual license based on cores. I'm sorry, but based on socket. And then in addition to that, we also have the annual service and support. So that's just for, you know, technical support and also the software upgrades. So in general, our license is simple, a single software license per socket, and it's perpetual license, including all the features. Back to you, Narendra.
All right, Vince, thank you. This one is again on AMD with the virtualization market being very intense. Give us a sense over here, Mr. Manmohan, on the question which reads, how is AMD's strategy allowed to acquire virtualization market with various virtualization software licensing available?
Sure, Narendra. AMD is strategically aligned to capture a major share of the virtualization and cloud market today. Today, we have got a significant presence in all the mega CSPs and local CSPs in India and Southeast Asia. The primary reason for it is the 7 nanometer FinFET technology. We are able to pack 64 cores in a single processor socket within the same power and data center footprint of that of our closest competition, which is Intel. Vis-a-vis, our competition can pack a maximum of 28 cores. So higher the core count ensures more VMs can be packed in a lesser footprint. Now, in addition to it, most of the VM software are licensed per socket, as our friends from AirDeck have said. Their license are perpetual, and VM softwares are licensed as socket. Thus, having more core license can be effectively used, and thus the TCO per VM reduces to nearly half that of our competition. So that's our thought and strategy behind capturing the virtualization market today.
Thank you, Manmohan. This one is for the products that Vincent Lee from AIC showcased to the audience today. The question is, can AIC system work with Sas Drive? Vincent?
Yes, yeah, this is Vincent. Indeed, the AIC servers can be worked with the Sas Drive without any problems. However, in order to perform the high performance from the AIC servers, and as well as working with some hyper-converged solution like AirDeck, we will strongly suggest customers to using the NVMe drives instead of SAS. Currently on the markets, you can refer from your supplier. Per GB cost for each driver from the NVMe or SAS will be almost the equal. So here we will strongly suggest the customers to using the NVMe instead of the SAS drives directly. Well, if you have some more interesting offline, you can share your questions to us, then we can reply you for more. Thank you.
All right, Vincent, I think, yes, there is a gradual adoption which is moving towards NVMe because of many advantages. I think we can pick up another question. This one I would see for AirDeck technology, Vince, go on. Because all these deployments would make a good impression when you have use cases referencing. So Vince, go on. Can you say some references of real deployments from ADEC technologies to share over here?
Yes, we actually have customers in different area, different use cases. For example, in financial services, in education, and also in governments. So it in all different kind of industries, so to speak. And our customer, our actually longest customer is actually in financial services in the US, and they have been using our product for over a year now, something like about 14 months. And in addition to that, there are also other companies and OEM partners that we are currently working on in different areas, such as in Southeast Asia, East Europe, and also in EU area. So we definitely have products that has been already deployed in actual production and as well as in OEM trial.
Okay, Vince, I think HCI is, we are finding a lot of questions on HCI solution. So I would put another one which I just received for you. In reference to HCI solution, kindly clarify on the load balancer. A virtual load balancer or an appliance based? Can you clarify and share some insights, Vince?
Yes. So there are two different kind of load balancer. I think I saw the question. The dynamic load balancing that mentioned in the product introduction PowerPoint, that's actually the internal load balancing, meaning that when you have lots of VMs running in different servers in the infrastructure, sometimes the load on each server may not be the same, because, for example, some VMs is busy sometimes and less busy some other times. So that dynamic load balancing that we mentioned in the product works with inside the product. So that's basically managing or distributing different VMs on different servers. So the servers CPU utilization, for example, and memory utilization are about the same. Basically, the variance of the CPU load and memory load are minimized. So that's the load balancer that we are talking about in the presentation. There is also certainly virtual load balancer that we are going to support. Currently, it's not in the product yet, but it will be in the upcoming release. And that kind of load balancer basically is kind of like you have multiple web servers with and you have a single IP address to the outside world, but it can actually distribute basically different requests to different VMs in the infrastructure. So that's an upcoming feature that we will have in the next release. I hope that answers the question.
I think yes, Vince. I think I'm getting a whole lot of questions around HCI. So with good respect towards the panel speakers, I would like to put up yet another question which is around HCI from you. The question reads, please suggest if these mentioned nodes are hypervisor license agnostic. So of course, hypervisor license agnostic usage of these solutions possible and how. Vince?
Yes. I'm not quite sure what exactly the question, so I will try to see whether I can, my answer is actually right for the question based on my understanding. If not, then, please follow up with another question. So our hypervisor license is actually perpetual license, meaning that there is a single license fee for each socket, and so that's a one-time license fee, and then the additional fees that you'll pay for is only it's no longer on an annual basis. It's no longer for the per socket software license. It's actually for the support and service, for software upgrade, and for example, bug fixes and things like that. So that is based on the it's about under, I would say, roughly 20% of the system cost. So so that's our licensing model. And we, on the other hand, we also support heterogeneous server configuration. So you in a single environment, it's unlikely that you would do that at the beginning, but in the future expansion of the infrastructure, when you scale the infrastructure to support more workload or provide more capacity, then you can actually, like for example, at that time there are newer processors and servers available, then you can actually put in or add servers with slightly different configuration into the existing environment. And certainly every new server that you add, there is a software license based on the socket, and also the annual support and service charge.
All right, Vince, I think that was a wholesome and very informative clarification. As I see in the question box, there are many questions still pending, but in the interest of time, I would encourage participants to move over to the breakout subject-wise chat room, which have been created and they're open. I would encourage participants to move over for a deep and a very direct discussion on subject areas. And with that, I would like to thank all the panel speakers from AIC, ADEC, and AMD. Thank you very much. And with that, I would like to announce the end of Q&A session.
Thank you for attending the webinar. Please stay around and do join us for breakout sessions for Tech Talk with our panel speakers. In each breakout session, we offer a raffle prize of $100 in form of a gift voucher from a leading e-commerce company, Flipkart. For you to joining Zoom groups with presenters, all the links of AIC, AMD, and ADEC breakout session will be already provided in the chat section. You may choose to click a Zoom room of your choice and gain an entry
to directly speak to the presenter over there. For all the presentation files being shown here, we'll be posting all files at our website www.aicipc.com. And lastly, please do follow us on YouTube, LinkedIn, and Facebook at the below links. With that, I'd like to conclude today's webinar, and I do, of course, look forward to meeting you in the breakout sessions. Thank you.